Hey guys, so we're going to continue with our intro to trigonometry in this video. Hopefully you've been understanding everything so far. The triangle that I've got here is the same one that we left off with at the end of our last lesson. So we've got a triangle, we've got a right angle over here, and I've labeled my angle theta. Over on this side we've got that the length of this side is 10 centimeters, and this side up here measures to be 20 centimeters, approximately, we'll say. Alright, so if you remember, this theta angle is always going to be made up of the hypotenuse and the adjacent side. The adjacent side, we know from last time we worked with this triangle, is down here. The opposite side is over there, and the hypotenuse is up here. Okay, so those are our three sides. And we talked about our three trigonometric functions: sine theta, cosine theta, and tangent theta. So sine theta is opposite over hypotenuse. Our cosine theta value is adjacent over hypotenuse. And our tangent theta value is, I'm going to move this down, tan theta equals opposite over adjacent. Alright, so those are our three trigonometric functions, and we don't have enough information because we don't have this adjacent side. We can't use any equation up here that has adjacent in it. So because our cosine theta equation has adjacent, this is not helpful to us. And because our tan theta has adjacent, this is also not helpful to us. So we have to use sine theta, and when you do the math, you get sine of theta equals the length of the opposite side first, which is 10, the length of the hypotenuse, which is 20. 10 divided by 20 is a half, or 0.5. Now, I'm going to write out the notation this time of once you get to sine theta equals 0.5, what do you do to get theta? Alright, so we've figured out so far, we've got sine theta equals a half, right? 0.5. Now, on a calculator, if you, this isn't something you can plug into a calculator right now. Now the sine, the next bit of this can get a little bit confusing. The notation for sort of undoing the sine function. So far we've got theta, but it's not theta equals a half, it's sine of theta equals a half. So basically we've done something to theta that spat out the value 1/2. We want just theta. So to undo whatever we did with this sine function, we write sine inverse of 1/2. So it's like sin with a little exponent of -1. It's not actually an exponent. This is just the notation. And then 1/2. So you would write theta equals sine inverse of 1/2. You might, depending on your calculator, it might say arc sine of 1/2. That's the same thing. Sine inverse and arc sine. You can use both of these. These are the same thing. And this you can plug into your calculator. You can plug in sine inverse, open bracket, 1/2, close bracket. Or if it doesn't say sine inverse, if it says arc sine, you hit arc sine, 1/2, close bracket, and it should spit out an answer. And the answer that it should spit out is 30 degrees. Now, scientific calculators can be a little bit complicated to use if you're not used to them. So basically, your button, the buttons on your calculator, you might have a button that says SIN on it, and then just above the button, maybe it says arc sine in like a different color, in like orange or something. Now, what you have to do for your calculator is you should have a button somewhere that says like second function, so something like second function, or maybe just second. you have to press that button, and now instead of putting in the sine function, it'll put in arcsine. So if you have sine written in big white letters, let's say, and arcsine written in small orange letters above it, chances are you'll have a button that's got something that indicates that it's going to activate the orange input instead of the white input. So to get arcsine, you need to hit second function sine button and then type in 1/2 in brackets. Okay? And what that should spit out is 30 degrees. If it spits out something else, don't worry about that yet. That's going to be something that just gets more complicated, so we're going to forget about it right now. If you do run into problems, let me know, and I will do my best to answer your questions if you have an issue. So basically this is how it works. You've got your sine value, you've got sine theta equals 1/2, and then you started with some theta value that you're trying to figure out what the theta value is, but we can't figure that out yet. What we've done is we've done something to the theta value. We've put it into this machine that doesn't give you the theta value, it gives you the sine of the theta value. It gives you the ratio of those other two sides that correspond to a specific theta value. And so it's telling you, well, I can't tell you the actual angle, but I can tell you the ratio of the two sides, the opposite side and the hypotenuse, created by this angle. And it tells you that the opposite side, if it's 1 unit long, the hypotenuse will be 2 units long. In other words, it's saying that the opposite side is half the length of the hypotenuse. So that's what this function does. You plug in theta into a machine, and this machine says, I don't know, I can't tell you what theta is, but I can tell you the ratio of the two sides created when you have this angle. And the ratio between those two sides, specifically the opposite side and the hypotenuse, is that the hypotenuse is exactly twice as long, or the opposite side is 1/2 the length of the hypotenuse. And then you have to undo the function. So you've said, once I put theta in this machine, it told me the ratio was 1/2. To undo that, you do this sine inverse function, that basically you take that ratio, put it in backwards through the machine, and it spits out the theta value. That's kind of a way that I was sort of taught to think about it, is that you can think of it as like a machine, like a little box. Think of it as you've got like this box down here, the sine machine, and there's like a space to put something in and a space to spit something out. So you take this theta value, you don't know what this theta value is, you chuck it into the machine, and it tells you, well, I can't tell you the value you've asked me for, but I can tell you the ratio, the sine ratio between the two sides in question for this angle, and it spits out an answer of 1/2. Okay, we calculated the 1/2 bit. So far this hasn't provided us with any information. What we have to do now is, instead of running the machine this way, we have to run the machine that way, backwards. If we run it backwards, we get the sine inverse function. Basically, you take that 1/2 that it just gave you, or that you calculated, or whatever, and you put in 1/2 into the machine, run the machine backwards, and it spits out a theta value of 30 degrees. And this is theta equals 30 degrees. So that's how this works. You can do the same thing for cosine, you can do the same thing for tangent, but this is basically the idea. You calculate sine theta, and then you sort of undo the function in your calculator. Don't try to do it by hand. And it'll spit out the theta value. There are a few numbers that you should know. There are a few values that you should memorize, and we'll get to it eventually. But basically, this is the process by which this works, and we'll talk a little bit later about the values that you should memorize. And in fact, you might have a quiz on it. One of you had a quiz on this last year, where you only have 60 seconds to complete the quiz. So it's not something that you have to know, but it's something that if you want to pursue something that involves trigonometry, it's just easier to memorize these things. Okay, so for me, I don't need to memorize that sine of 30 degrees is 1/2, but it's beneficial to me. With the work that I'm doing, it's just an advantage that I just memorize that rather than having to look it up every time. The same way that it's an advantage for me to know that tangent of 45 degrees is 1. Alright, so something like that. So we'll go through all of those values another time, but basically this is how it works. You have your 3 sides to the triangle, you need to know at least 2 of those sides, and then you can use one of these functions to figure out the angle. First you figure out the ratio, then you run it backwards through the machine and it spits out your theta value. Now there's something here that we haven't actually covered yet. So we've talked about the sine function, we've talked about the cosine function, we've talked about tangent, but there's actually a few more that we haven't talked about. Okay, so I'm going to get rid of this and we're going to talk about the remaining functions. You should write this down. Not because I'm going to test you extensively on it, but just because it's good to know and it's good to refer back to, because if you get it wrong the first time and never refer back to it, the rest of this can get very confusing. Okay? So basically we've got our sine theta value is going to be the opposite side over the hypotenuse. Yes? Now, there's a similar, so we've got our, let me write out the 3 that we know. We've got sine theta is opposite over hypotenuse, cosine theta is adjacent over hypotenuse, and tan theta, that looks like a B, tan theta equals opposite over adjacent. Now there's another function, it's similar to sine, but basically it's just these 2 things flipped over. So it's called cosecant, and the short form is CSC. I'll write the word up here. Cosecant is CSC theta, which is basically hypotenuse over opposite. So it's hypotenuse over opposite. The opposite of cosine, well not the opposite, the reciprocal, the flipped over version of cosine, hypotenuse over adjacent, is called secant. So that's secant, which is hypotenuse over adjacent. And then the opposite of tangent, or the reciprocal of tangent, is called cotangent. Cotangent. Cotangent theta is basically just adjacent over opposite. Okay? So these 3 over here, sine, cosine, and tangent, these are the primary trigonometric functions. Okay? These over here are secondary trigonometric functions. So basically, if you notice, because cosecant theta is just the flipped over version of sine theta, if you ever look up what CSC theta means, you might see something like basically it means the same thing as what that says, but you might see it written as 1 over sine theta. It's basically the flipped over version of sine. Similarly, you might see secant theta written as 1 over cosine theta, and you might see cotangent written as 1 over tan theta. Okay, so these are 3 things that you should be aware of. I won't test you on them. You won't have an exam question that says calculate secant of this angle and I'll give you a diagram and stuff. I'll only ever ask you for sine, cosine, tangent. I'll only ever ask you to work with those, but these are important because a lot of people, what they'll do is they'll confuse 1 over sine theta, that is cosecant theta, they'll confuse it with sine inverse of theta. This and this are not the same thing. Okay? Sine inverse is undoing the function completely, which is why I drew it with that machine. You've got that machine, and it's your sine machine. And basically, so the sine function means you put something in here, and it spits it out that way. The inverse, that arc sine, means that you put something in that side, and it spits it out this side. Cosecant isn't the same as undoing the function. It's almost like keeping the function the way it was, but I guess like, I don't know, flipping it upside down or something. I don't know. Something like that. You could think of it as you haven't actually done anything to undo the function. All you've done is sort of just you're doing a different function. It's not the same as this. So don't worry about trying to draw it with this kind of machine sort of setup that I used before. But it's basically, the point I want to get across is that cosecant theta and this sine inverse of theta are not the same thing. Alright, and it's the same for secant and the cosine inverse and all of that. So don't confuse those two things. I'm going to try to not worry about this stuff so much because otherwise I'll be running the risk of confusing you guys. So we won't worry too much about that stuff, but I just wanted to bring that to your attention before it comes to time to write a test. Alright, so if you have any questions, once again, leave a comment, send me an email, get in touch with me somehow, and I will get back to you as soon as possible. Otherwise, I hope you guys are enjoying this unit and understanding it, and I will see you in the next video.